Assalamualaikum. Hi guys. We are going to continue with VSEPR theory in this video. This is the structure for CH4, methane. And when we learn before this about the Lewis structure, you will draw the Lewis structure for CH4 like this one. However, in reality, the structure for CH4 is this one. And it is in a form of tetrahedral. And you can see that I show by using three-dimensional arrangement of atoms in this molecular geometry. So what is molecular geometry? Molecular geometry is the 3D arrangement of atoms in a molecule, where this geometry will affect the physical and chemical properties of that molecule. We are going to determine the molecular geometry by using valence shell electron pair repulsion, VSEPR theory, or another word that I can pronounce it as VSEPR theory. What is VSEPR theory? VSEPR theory is defined as the electron pairs surrounding a central atom will repel one another. This electron pair is referring to two types of them, which are bonding pairs and lone pairs. So that is what I'm talking about electron pairs. So let's focus with each of them. Bonding pair and lone pair electrons will arrange themselves as far apart as possible in order for them to minimize the repulsion. So this is how you are going to calculate and determine the number and geometric arrangement of electron pairs around the central atom. By doing this, you can predict the shape of covalent molecules and polyatomic ions. And we can only consider sigma bond in predicting the molecular shape, or another term, molecular geometry. So this is what we are going to learn in VSEPR theory. And please remember, as I mentioned before, by using the structure of CH4, actually Lewis structure cannot tell us the exact three-dimensional shape of that molecule. That is why we will use VSEPR theory. We know that in VSEPR theory we are going to determine the electron pairs. So there are two types of them. The first one is bonding pair and the second one is lone pair. I'm going to focus based on their electrons. So bonding pair electrons is where those electrons are attracted by the nucleus of two bonded atoms. So usually I will illustrate them as one line, and this line is equivalent to 2 electrons. And this bonding pair occupies less space. Next, we have lone pair electrons. Lone pair electrons will experience greater repulsion from neighboring lone pairs and bonding pairs. That is why lone pair electrons will occupy more space compared to bonding pair. I'm going to illustrate by using 2 dots. So this is equivalent to 2 electrons. Then we can determine the order of strength of repulsion between electron pairs, where between bonding pair and bonding pair is the weakest repulsion, and lone pair with lone pair is the strongest repulsion. That is why when you have a molecule with more lone pairs, the electron pairs in that molecule will repel one another and arrange themselves as far apart as possible in order to minimize the repulsion. So from this strength, we can divide our molecules into two categories. The first one is the central atom that has no lone pairs. For example, I got CO2. When you draw the Lewis structure, there is no lone pairs at the central atom, which is carbon atom in this case. Next one, the second category is the central atom has one or more lone pairs. For example, I take it NF3, where you can see that the nitrogen is our central atom with one lone pair. So these two categories are what we are going to explain in the next video in order for us to draw the shape of them. That's it for now. I will see you in the next one. Bye!